Hey everyone, welcome back to this machine learning and data science course. And in this section, we are going to learn about model diagnostic. What exactly is model diagnostic and why we need them? But before that, let's look into the problem statement which made us to reach to model diagnostic. So let's say if our hypothesis, that is our model, whatever model we have trained, is making a huge error, that is large amount of error in its prediction, then you might try different things to make your model good. So let's say you have trained this model, and when you find that is the error function, okay, so j exactly is the error function, is very high, both in train, that is j train is also very high, and for j test it is also very high. So you might try different things like get more training example, try smaller sets of features, try getting polynomial features, or uh, increase the data set, try getting additional features, get more columns. You may try out different things. Now all of these take a lot of time, massive amount of time. So first thing you might take, get more data. The second thing you might try it is using smaller set of features, smaller set of features or column. Okay. Or you might just increase using larger set of features, add more features if you can get it somehow. Or you can try polynomial features, poly features. Or you can also use with if you are using a generalized regression, then you might increase the lambda values. You might increase the lambda values, or increase the lambda values, or you might decrease the lambda values. Let's keep these two for now. Okay, let's discuss about the four. So out of all of these, if you try any one of them, it will take massive amount of time, get large amount of data. If your data, you are having 10,000 data points and you see your model is not working, then you might think, let's get more data. Then this might take you 3 to 4 months. And then after 3 to 4 months, you see that getting more data didn't give me a better fit. Then you tried out a different thing using smaller set of features. Then you tried out this, it took you 1 month or probably 15 days to this, and again you said the model didn't work very large. You tried with large set of features and you saw that the feature went your model works quite well, not the best but quite well. Then you tried out polynomial features and you see that your model works really good. So all of these took you, again the large set might took you more than 3 months. Trying polynomial feature again took you 1 month. So all of these took you almost near to 9 to 12 months. Now you have wasted almost 5 to 6 months of your time doing something which wasn't really helpful for your model. So for this, we need model diagnostic. It can give us a better guidance on what might be more fruitful thing to try to improve our model. So after doing a bit of getting an insight of our model, that is getting a diagnostic of our model, we can decide that if we should get more data, or we should use a smaller set of features, trying increasing the lambda value, decreasing the lambda values, getting polynomial features, etc. Doing the model diagnostic, we can get a glimpse of what we should be using. So rather than wasting 6 months on something which wasn't really helpful for your model, you would be doing something which will be actually helpful for your model. So this will kill your time, and it will also give you more insight of your data. Now, so for jumping into this, we should be knowing a bit about the errors. What are the different kind of errors in machine learning? There are basically two kinds of error, that is reducible error and irreducible error. So what I mean by this is, reducible errors are errors which can be reduced, but irreducible is mostly because of noise and it cannot be reduced. So reducible error are those errors whose values can be further reduced to improve our model. You can actually improve the reducible error to make our model better. Okay, It will increase our model accuracy or whatever metrics you are using to a much better level. They are caused because our model's output function does not match the desired output function and can be optimized. Okay, what happens in this kind of case is the model output model, the hypothesis that we have got. Okay, the hypothesis, the h not of x, h of x that we have got is not quite the same for the test set. Okay, it does not actually match the desired output function, so it can be optimized. Okay, so let's say we have hx and we have h of x. These two are not quite equal, so we can do different things to make this quite near to each other and improve our models successively. But irreducible errors are error which will always be present in our machine learning model because of unknown variable or whose values cannot be reduced. So basically, this can be known as noise. So that's a bit about reducible error and irreducible error. Reducible error, there are again two things. We have bias and then we have variance. Let's understand both of them.